Alright, boys and girls, welcome back to the drive-through. Hope everyone feels good about their first little assessment that they took, and you did as well as you wanted and enjoyed your meeting with Mr. Yule. And we're moving on to 1-6. Okay? Pause the video and read your worksheet. Read the paper here, or just read the PDF if that's what you're working off of. And you'll see that we've got a ton of candies here. So we've got 15 pounds of candy times 180 pieces per pound. Okay, so that'll give us how many pieces we'll have. So we've got 2,700 pieces of candy in this candy machine. Okay? Represent the number of candies in the machine for any given number of customers. Well, what's each customer do? They take out about 7 pieces of candy each time. Okay, so after 0 customers, we had 2,700. After 1 customer, we would have whatever 2,700 minus 7 is, so 2,693. 2 customers, 2,686, I think. 3 customers, 2,679, and it keeps going. But hopefully you're starting to think like, come on, I don't even need a table anymore. Well, good for you. That's good. Hopefully you understand that the slope in this problem is -7. Okay? And each time that somebody gets it, each time a customer comes and gets candy out, we're getting 7 less pieces of candy. So if you think about what this y equals mx plus b means, okay? First of all, the y and the x are going to stay there. That's our input and our output. X is the input, y is the output. So what is the m and the b? Well, the m is the slope. So in this case, that's -7. Okay? And what is the b? Well, that's the y-intercept. But really, what does that mean? It's where we start. In this equation, we would have been starting up here and going down ever so slowly. I guess it would be starting right here and going down ever so slowly. This would be 2,700 candies. So that is where we begin. And that's the best way to represent it. Now, you could put C equals, so the number of candies equals -7 times N, the number of customers, plus, that's fine. I don't care what you call your input and your output variables. Okay? Now, represent the amount of money in the machine for any given amount of customers. Well, I think it's just going to be the money is it a quarter each? A quarter each, so 0.25 times n. Well, what's the b? Well, if we have 0 people come to our inn, where do we start? 0. So you could put plus 0. This could be an x. It could be C is equal to 0.25n. They're all the same. It's all good. Okay? All right, to avoid theft, the store owners don't want to let too much candy collect in the machine, so they take all the money out when they think the machine has about $25 in it. The tricky part is that the store owners cannot tell how much money is out in the machine without opening it up, so they choose when to remove the money based on how many candies are left in the machine. About how full should it look? Okay, so we just got to do some thinking here. We want $25. Well, it's what's $25 divided by 25 cents? Okay, and that's going to be 100 customers. So if 100 customers come and put in a quarter, we'll have $25 in the machine. Hopefully you guys understand that. And how many, if we have 100 customers come, and there's 7 pieces of candy for each customer, that's 700 pieces gone. There was 2,800 pieces to begin. What are they asking for? About how full should the machine look when they take the money out? Well, what's 700 out of 2,800? Well, that's a fourth. Or if you just put that in your calculator, it's 0.25, or it's 25%. So, when it is about 25% empty, we should cash out. All right, find the missing term for each arithmetic sequence. What's an arithmetic sequence? It's every single term differs by the exact same amount. So we have a slope. These are linear progressions. So from 5 to 11 is 6. Since it told us it's arithmetic, then I know that the next one we will add 6 and get to 17. When you add 6 to 17, you get 23, 29, 35. The common difference was 5. Okay? Let's see. It's arithmetic. So, the first one was 8. The second one, we don't know. The third one, we don't know. And the fourth one was 47. So how did we get from 8 to 47? Well, what did we do? We added 29. Is that right? No, we added 39. So, if we added 39 to skip 2 spots, we need to divide that by 2, and that's going to be 19.5. That's going to be my guess for this one. 19.5. Let's see, what's 8 plus 19.5? That's 27.5. What's 27.5 plus 19.5? And that's 47, but that's not right. Hold on. Ooh, I need to divide it by 3 here. Okay, so notice that I made a mistake there, which is totally normal part of this math. I did some bad math. I didn't divide by the number of spaces that we were adding. I divided by the number of spaces that were blank. I actually need to divide this by 3. Watch how that works. 39 divided by 3 is 13. Now let's try 13 as the common difference. Let's see if we did that one right. So 8 plus 13 is 21. 21 plus 13 is 34. 34 plus 13 is 47. Now we got it. So, we were missing 2. I had to divide the difference by 3. Let's see how we can do this in number 5. So in number 5, we'll do the same thing. The first term is 5. We don't know the second term. We don't know the third term. We don't know the fourth term. But the fifth term is 25. So we don't know what this is. We don't know what this is. We don't know what this is. So notice, we got to add 4 things. So 25 minus 5 is 20. So we've added 20 from the 1st to the 15. And we've added 20 by adding the same thing 4 times. So I think that n here is 5. Let's see, does that work? Let's fill them in. 5 plus 5 is 10. 15, 20, 25. All right, much better. Okay, you guys do the evens on your own. Two consecutive terms in an arithmetic sequence are given. Find the recursive formula. Okay, so the recursive formula is how do you get from the first one to the second one? And this is an arithmetic sequence. All right, so f of 3 was 5, f of 4 is 8. Arithmetic, that means we add the same thing, add or subtract the same thing every time. Okay, so we're adding 3. So if f of 3 is 5, f of 4 is 8, f of 5, the fifth one will be 11, the sixth one will be 14. So the recursive formula, we tell it where to start. So start at 5, and then for any other number, take the number that came before it and add 3 to it. Okay, hopefully you're just getting more comfortable with that recursive, I guess just the notation of it. The second one was 20. Oh, hold on a second. F of 1 is not 5 here. F of 1 is not 5 here. F of 3 was 5. So f of the third one is 5. The second one would be 3 less than that, which is 2. And the first one would be negative 1. There you go. That was tough. Okay, so here, f of 2 is 20. I just prefer to have a table. F of 2 is 20. F of 3 is 12. So let's see, it's gone down 8. So f of 4 is going to be 4. Subtract 8 from that. F of 5 is going to be negative 4. So, how do we get, this is going to be 28. So the recursive formula, the first term is 28. Okay? And to get any other term, f of n, take the term before it and, whoops, we're subtracting 8 every time. So minus 8. All right, now we have a geometric sequence. Geometric sequence, we multiply to get to the next term. Hopefully you guys are picking that up in this chapter. Okay. So, f of 3 was 5. F of 4 was 10. So the third one was 5. The fourth one was 10. So the fifth one will be 20, and the sixth one will be 40. Okay, to write the recursive function, we need to instruct our computer what the first term will be. So look, we're going to have to, this is going to be tough. 2.5 for that one, and the first term will be half of 2.5, which is 1.25. So f of 1 is 1.25. F of n, any term, take the term previous to it and double it. Okay? F of 2 is 20. F of 3 is 10. So now it's getting smaller. The second one is 20. The third one is 10. So what's the first one? The first one must be 40. The fourth one would be 5. And the fifth one would be 2.5. And for the recursive formula, the first term will be 40. To find any term you want, take the previous term, that's what recursive is, and multiply it by a half. Or you could say divide by 2. I would take that, no problem. Okay, so now we're back into explicit functions. F of n is 2 to the n. Find f of 5. So f of 5, take out the n and put in a 5. So that's f of 5 for this one is 2 to the 5th, which is 32. Okay? F of 0 will be 2 to the 0, which is 1. I want you to think about why that's true. If you don't understand, I'd love for you to ask me. F of 4 for the next one will be 5 to the 4th. Good chance for you to practice typing that into your calculator. Should be 625. F of 1 is 5 to the 1st, which is 5, and I think you guys will be fine. Well, we should do 15 and 16 because they are different. 15, f of 3. Well, that's negative 2 to the 3rd power. Well, we do parentheses before we do exponents. So that's negative 2 times negative 2 times negative 2, which is a negative 8. F of 0 is negative 2 to the 0, which is positive 1. Anything to the 0 power is positive 1. Well, in number 16, f of 3, that's negative 2 to the 3rd power. Well, now we don't have parentheses, so we do exponents first. Well, when we do the exponents, we ignore this negative. That's a multiply. So 2 to the 3rd is 8 power. We do our exponents first. Then we apply this negative, and you still get negative 8. Here's where it'll look different. F of 0 is negative 2 to the 0. Well, it's negative 2 to the 0. So 2 to the 0 is 1 times a negative. That's a negative 1. So that's tough stuff. Love to have a little conversation with you about the difference. Have a great day. Boom!